Hi everyone, this is Math 176, and this is your Section 6.3 lecture video. In this section, we are dealing with trigonometric functions of angles. Let's suppose you have theta as an angle in standard position, and P of x comma y is a point on the terminal side for that angle theta. If r is defined to be the distance from the origin to this point, then you have the following trigonometric definitions. So for that angle theta, your sine of theta is that opposite over the hypotenuse. So I forgot to label the opposite side of this triangle here. Let me fix that. There we go. Your cosine is still the adjacent over the hypotenuse. Your tangent is the opposite over the adjacent. And on your right, you have your reciprocal functions defined for you there. So for any point that's in the xy plane, this point has an angle associated with it. And if you were to draw a triangle with that point and this radial distance r, here is how your trigonometric functions will be defined. These are still equivalent to the SOHCAHTOA that you are used to and the SOHCAHTOA that you're used to from the previous section. You still have your Pythagorean and also reciprocal identities for sine, cosine, and tangent. And you still have, like I said, your Pythagorean identities as well. Sine squared of theta plus cosine squared of theta still equals 1, and so on and so forth. You are also introduced here to the definition of a reference angle. So let's suppose theta is an angle in standard position. The reference angle theta bar is the acute angle formed by the terminal side of theta and the x-axis. So just in case you've forgotten some of your geometry, acute angles are angles that are less than or equal to 90 degrees. Let's actually talk about where reference angles are often used. Let's suppose that you were asked to evaluate a trigonometric function at some angle that is more than 360 degrees or more than 2 pi radians, like this example here. You're asked to evaluate sine of 13 pi over 6. If you look at this picture right below, I have drawn for you that angle of 13 pi over 6 in the black. It's a positive angle, so it goes in that counterclockwise direction. That angle, it's going to be coterminal with this angle in the hot pink, pi over 6. 13 pi over 6 and pi over 6 are coterminal angles, and pi over 6 is an angle that is less than 90 degrees, right? So pi over 6 is the reference angle for 13 pi over 6. Since both of those angles, 13 pi over 6 and pi over 6, they are in the same quadrant, and they're both coterminal, you must have that sine of 13 pi over 6 is equal to sine of pi over 6. Sine of pi over 6, you know that's a special unit circle value. This is equal to 1/2. I have drawn for you a few pictures here. So if theta is an angle and theta bar is its reference angle, you have a few pictures here. So for an angle that's just in quadrant 1, that's less than 90, theta and theta bar would be the same. For an angle that's in quadrant 2, I have drawn for you theta bar here, and I've drawn for you other pictures for when theta is in quadrants 3 and also 4. No matter what angle you are given, you should be able to draw it and determine what the reference angle will be. Now, as far as drawing these angles are concerned, we will talk about that in tomorrow's lecture. I will see you tomorrow for our Zoom meeting.